Hey, I'm Nathan Brand with Cole Ironworks, and we're here in Phillip, South Dakota today at Scotchman Industries with Jerry Crutch, the president of Scotchman Industries. Phillip tagged along, our lead process engineer, and Brooke Formanek, which is the marketer here over all the marketing for Scotchman. And we're taking a tour of the facility today, looking at their processes and seeing how they're manufacturing all of their stuff in-house, bringing some of it in, some of these beautiful saws behind us, as you'll see in the video. But we just wanted to highlight some American manufacturing and see how small and mid-sized shops here in the US are doing it.
So again, Scotchman builds 13 different models of an ironworker. We go from 45 ton to 150 ton. This is a 50 ton, so it's basically one of the small machines that we build, but every ironworker comes with an angle shear, give you a nice, clean, non-distorted cut. An ironworker is kind of like a Swiss Army knife. I can do one of a dozen different fabricating functions. This is the pipe notcher. So I notch it, I rotate it, notch it again, and you can saddle it and you can weld it. Also built into the ironworker is a plate shear, so I can take my flat iron and I can shear it. Gives you a nice clean sheared cut. Of course, this is the punch station. Every ironworker is rated on the tonnage in the punch. So if you buy a 50-ton machine, it's rated on what that machine can punch.
Got it.
This machine will punch a 13/16 round hole in 3/4 plate. That equals 50 tons.
Ooh.
You can punch round, square, oval, hexagon, keyhole, almost any shape, any size. And the beauty of this particular machine is a 3-station turret. So I can punch a different shape, different size in each one of the holes. And that's what a Scotchman hydraulic ironworker does. And you can take these tools out and you can put a press brake in for bending. So you got a dozen different tools that you can swap in and out of the machine to make it extremely versatile.
And you were talking about the ease of moving these in and out. You guys have this table, everything just slides in, quick bolt.
That's correct.
You're ready to go.
That is exactly right. I'm gonna turn this skid and let me rotate this just to get it out of the way. But yes, if I remove the bolt, I can take the angle shear and the pipe notcher off and then put a press brake in.
Right.
I can take the press brake out and put a channel shear in or a rod shear. I've been into so many different customers' plants. They take all the tools out. Now you use your own imagination and you build the tool you need.
Right.
And I'll walk in there and say, damn, we do that too. I didn't know we could do that. Mr. Customer uses his own imagination to do what he needs to do.
Right.
Everything that we walked through today
Yeah.
was done in here in 1971. So
That's awesome.
we've grown a lot and added on and added on and added on. And
Yeah.
so, and usually once a week, maybe once every 2 weeks, we have, that's our trailer that we hire a gentleman to go to Minneapolis and pick up whatever we need.
Gotcha.
Here we have some flame cuts and then you get some bar stock, so every load is a little bit different, of course. But again, the flame cut, as I mentioned earlier, we do 1 inch and thinner.
Yeah.
Anything thicker than 1 inch, we have a flame cut out in Minneapolis. So, so this is the steel warehouse.
Okay.
You look in here and you see there's not a lot of stock.
Yeah.
But there's $6 million worth of material in process all the time.
Sure.
So,
How much of that do you keep on hand? So you got $6 million of work in process, but I mean, raw material on the shelf, you're bringing it in and using it immediately.
we are.
Okay.
For the most part, we are.
Yeah.
We bring it, we get it when we need it. And right now, it's a little different times today.
Sure.
We struggle every week to get something.
Sure.
Can't get it. Our humidity level here is extremely low, but we can get extremely hot.
Yeah.
This fine little town we live in, we can be the coldest in the winter in the nation,
Yeah.
usually for a week or two, or we can be the hottest in the nation in the summertime for a week or two.
Yeah.
So, you know, it's 105, 6, 7 degrees outside. We keep the thermostat set at 72 and pretty comfortable.
That sounds...
Something else that this area is known for is the artesian thermal water underground.
Okay.
We have our own well that we dug back in 1974.
Okay.
Our well is about 2,700 feet deep. Wow. When we first dug it, the water came out at about 120 degrees. It's cooled down now. It's only about 101, 102, but this building alone has 8 miles of water pipe in the concrete. We run that hot water through the concrete to help heat it in the wintertime. The city has a well that they dug back in the 50s.
Yeah.
It's 4,700 feet deep. The water comes out of the ground at 165 degrees. And it still comes out of the ground today at 165 degrees. The school has a well. Can't tell you how deep it is. I can't tell you how hot it is because I don't know, but it heats the school. They piped it down to Main Street. It heats the bank. It heats the Ford garage. They piped it to the hospital and the nursing home. It heats the hospital and the nursing home. There's a lot of ranchers that have a artesian well that they pipe to their water tanks to water their cattle. And so,
that's amazing.
But again, you see over here is these are all the flame cuts that we have done by Ryerson in Minneapolis. They cut the shape, the profile that we need, and then we do all the machining on it. You know.
So you do. I mean, you've got that raw material sitting here. How long would you say, like that last frame in the bottom of that stack? How long is that going to be there?
30 days.
30 days. So about a month. That's about where we're finding is a nice sweet spot for holding material, so that I don't have all my cash tied up in it.
That's right.
But
But most of your cash is tied up in labor. At least ours is.
Sure.
So raw material is a whole lot cheaper than finished material sitting on a shelf.
Sure.
So years ago, before we got into all the CNC stuff, we would make 100 or 200 pieces and set them on the shelf.
Right.
You get down to 10, you'd make another 100 or 200 pieces.
Yeah.
Now we're making parts today that we need tomorrow.
Yeah.
So we don't have near the amount of finished inventory sitting on the shelf.
Right.
Everything you see is all done by a CNC machine of some sort.
Sure.
This is a Mighty Viper.
How long have you guys had this?
I'm going to say we've had this machine maybe 10 years.
Okay.
Maybe. So here's a raw frame that we bought from Ryerson. They cut it out.
Right.
We weld the scab on it. In this particular frame, we fly cut the sides off because the beam slides in between the front and rear frame, so it's got to be flat and square. Yes. And then we chuck it on the tombstone, depending on what we're doing. So we have 2 frames on that tombstone, and the tombstone will rotate. The end mill or the drill bit or tap or whatever it's going to do is going to do its work. This machine holds 64 tools on the top, and when it's done with that tombstone, it brings it over here, slides it on here, and this will rotate and push off another tombstone.
So you're able to do setup and tear down independent of the machine running.
That's correct.
Yeah. That's...
The rule of thumb is when the machine is machining, and he's over here taking a part off and putting a part on so it's ready to go when that one's done.
Right.
That machine has 4 tombstones. These 2 machines have 26 tombstones, and it's got a robot that goes up and down the rail to pick out the tombstone. It's either going to put a tombstone in the machine to be machined, or it's going to take a tombstone out of the machine and bring it over here where they take the finished parts off, put raw parts on, and then it'll go put it away and stage it until we need to make that part again. There's actually a total of 4 load and unload stations. There's 2 here, and then there's 2 more down on the other side. So I have 2 operators. Basically, one operator's running this machine, the other operator's running that machine, and they're just changing parts in and out. But these 2 machines run unattended at night. Again, my guys work 4/10, so they come in at 5 a.m. in the morning. They go home at 3:30 in the afternoon, Monday through Thursday. At 3:30 in the afternoon, we push go, leave the air compressor on, and go home. So if it happens to break a tool, When it's running at night, that tool will have to hit a probe. Every time it changes the tool, it hits the probe. And if the tool doesn't make the probe, that means it broke, so it shuts off.
Got it.
But these two machines will do the bulk of our parts as far as machining wise, day in and day out.
And you said you just bought these a couple years ago.
No, these machines are, that machine I bought 5-6 years ago. These machines are 15, 16 years old. Yeah.
Gotcha.
Yeah, they're.
So this was where the other 3 that you replaced.
That I replaced.
This is the square footage that you used to. I got
Yep.
So what did you do in the interim while you were swapping the? I mean, were you running those old mills?
Well, we ran the old mills until the new ones showed up.
Gotcha.
And we had to take the old ones out because they sat right in this line.
Right.
So there was, a 2-week window.
Yeah. Right.
So prior to that, we knew they were coming. We just machined a bunch of extra parts and put them on the shelf.
Yep.
So,
Yep.
But they're an amazing machine.
Yeah.
And we'll look at the back side of these machines in a few minutes, but they each hold 164 tools inside. We're not 100% lean manufacturing, but we really try hard to. If a guy needs 5 wrenches within a 5-foot radius, so he doesn't have to walk that 5 foot, he can just, we'll get him 5 wrenches. So,
Yep. We're pursuing the same goal.
Movement is key.
Yep.
Yeah, certainly is. It goes back to that time is money.
Right.
When he's walking 5 foot to grab an $8 wrench,
Right.
buy him another $8 wrench.
Buy him 10. So that's something that we've really struggled with in our shop is, parts in process getting to the people that need them, right? Because it's like the guy over here in an assembly cell that's putting the stuff together, running out of a part. How do you guys get that information to the people that need to make more?
Well, we have a very detailed inventory system.
Okay.
So the shop order comes out. I've got a guy that all he does all day long, 10 hours a day, is drive a forklift, move parts. That's all he does.
Yep.
And 9 times out of 10, he's getting the part to the location before that guy runs out of a part. Rarely.
So how does he know? Is he just looking at bin quantities and stuff, or?
No, he doesn't. He doesn't. He just grabs a pallet to come off of a machine, and he knows it needs to go get put away.
Got it.
So he goes and puts it away, and it's always put away before the guy needs it.
Gotcha. So you guys don't have like a central inventory location then that stuff's getting pulled out of. It's coming out of the mill and going right into the cell.
Yeah, it's going right into the stall that it needs to go into. Yeah. So here's a raw frame. When I say raw frame, it's completely assembled except for the electrics and the hydraulics. So we'll take this frame, bring it over there to Chuck. He's going to make it look like this one, and then we take it to paint when Chuck's done.
Got it.
I got 3 assemblers assembling machines all day long. Happy to say everything that's built, sold. It's all going out the door.
Got it. So you're not holding any finished inventory then? It's all sold. Are you building to an order?
Yes and no. We always have raw material that assembled.
Right.
But I guess we do get, when we get an order for a machine, we'll grab that frame that's already 2/3 done, bring it over here and assemble it and get it out the door.
Got it.
To make sure it's the right electrics.
Sure. So you're holding it kind of, that's your point, your last point of variation is the frame, you've got all your frame options set, and then the electronics and hydraulics, and that's where you're making the
We hate to finish all the machines and then it's the wrong voltage.
Right.
And then I got to bring it back in and take the single phase motor out, put a 3-phase motor in, or vice versa.
With that, figuring out that process for sure.
Because now, if you got to do it over again, it's just more time you got invested in it.
Absolutely.
And this, everything that we looked at prior to was machining centers. Here's our lathe cell. I've got 3 DMG Moris, and then I got a Mazak over on the other side. That the Mazak just makes the punches and dies, and it runs unattended at night as well. So, as I mentioned earlier, we make over 9,000 different parts, and we make those parts numerous times a year.
Yeah.
But we're making parts for obsolete machines. And so they're doing something different every day, every week. All we do here is make punches and dies.
That's slick.
Whether you're making numerous size rounds, or whether you're making a hex, or whether you're making an oval slot. This one's got a bar feeder on it. So We load the bar feeder up with as many pieces of raw stock it'll hold, and then let it run all night long. But we'll tell it we want 15 of those, 27 of them, or whatever our inventory thinks we need. So then it runs and it'll make the quantity we need of an oval, and it automatically changes the size to do a round or a hex or whatever. It's programmed in there to do that. It's programmed in there to put the size on it. This is 7/16 by 1, and the machine engraves the size on the punch and the die. We could go to 4 or 5 different manufacturers that all they do is make tooling.
Right.
But our question is why? Sure. They're making a profit selling them to us. Why don't we start from scratch and put that profit in our pocket? So we do them all ourselves.
Well, then do you also do custom tooling, right?
Yes, we do.
Is that application based, like direct order from the customer?
Yep.
And,
He'll send us a drawing and we'll say, yes, we can do it, and this is how much, or we'll say, no, sorry, we can't. But we've sold dozens and dozens, if not hundreds of machines over the years, not because the guy needed an ironworker.
Right.
He needed to do that one special thing that we built, and we made sure it fit on an ironworker to run it.
Right.
So we sold a machine in the process.
Right.
Then we do all of our heat treating back here in the corner. So every piece of tool steel, whether it's a punch and a die or whether it's a shear blade, we harden them all. We don't oil quench anything. Years ago, we used to oil quench.
Yeah.
Flames would go up 15 feet.
Yeah. So we outsource our heat treating, and it's an old school shop, been there since 1940, and it's wild.
Yeah.
We've got a video on the channel showing. I mean, when they dunk those tanks in the oil.
We finally quit doing that. It gets black. So this furnace runs it, and you can look down in that hole. This furnace is running at probably close to 1,700 degrees.
Yep.
And then we draw the heat out slowly.
Wow.
And by the drawing process is what makes it hard. And once we go through the 500-degree temperature a couple of times, then we just air cool. And our Rockwell on all of our tooling is 57, 58 Rockwell. And it's got a sand, it's a heat treat sand. Don't know what it's made out of, I have no clue. But we run air through the bottom of all of these, same way with this one. And that bubbles.
This is an electric furnace heating sand.
Yes.
Wow.
Yes.
Because in your video, I saw him pulling it out, and I saw it, and I thought, well, it's salt. They're doing molten salt.
Yeah, no, it's
I've
sand.
never seen sand.
It's sand. And it's a heat treating chemical.
Sure.
But that one there is, even though you can't see it, it's bubbling too. And and that just ensures that every molecule on that piece of steel in there gets the same evenly heated. We have a customer that'll say, can you make this for us? Or send us a drawing. Can you do this for us? Some guy wants to come in and shear that out.
Got it.
We do it with a punch.
So does he send you this application? Like he's sending you this part, says I need to make this.
That part he sent us. Sometimes they'll just send us a drawing. Sometimes they'll send us the finished part.
Yep.
Sometimes we'll request a finished part. And here this guy wants to smash it and punch a hole in at the same time. So I'd hate to guess how many iron workers.
As a
not
result
because
of
the
this.
guy needed the iron worker. He needed to do this.
You solved the problem.
We solved the problem.
So do you have a team of guys that work specifically in the, like this is their full-time position?
We got one guy.
You got one guy?
One guy. He draws it up, he prices it, and he builds it. We ship out somewhere between 100 and 150 UPS packages a day, replacement parts, punches and dies, whatever.
And you said that's available for every machine back to 1967?
Yes.
Wow.
Yes. Yep.
So do you have, how? Do you have records back?
Oh, yes, we do.
Yeah?
Yes, we do.
Wow.
Yep.
Very cool.
And then a customer will order an iron worker. So we build the machine, we bring it down, and then they'll buy 2 or 3 pieces of tooling with it. So they'll package the tooling and ship it on the machine.
So you're storing finished tooling out here?
That's finished tooling.
Okay.
Yep. We keep track of every part we make.
So if it comes out of the machine, you know you have it.
We know how many seconds it takes to make every piece in this place. So and the next time we make it, if we make it faster, we want to know why. If it took longer, we want to know why.
Right.
And these machines that we have in here, most of them, we take the trade shows, just about anything that's on a skid, that went to our last trade show.
Gotcha.
And maybe the next trade show, we'll clean it up and we'll send it to the next trade show.
Got it. So you've got special skid, that's slick.
Everything we send to a trade show goes on a steel skid. That way we don't have to take it off, we don't have to put it back on. It doesn't look half bad in the booth.
No.
Customers from all over the United States send us their dual blades back, and Karen sharpens them and UPS them back again. It's got an oil-based coolant in them, and as soon as she turns it on, it's going to flood that stone that's going to grind the teeth. Them stones are extremely thin.
Oh, I believe it.
So that oil keeps them lubricated. But these machines are about $180,000 a piece.
Right.
Just to sharpen we charge 12 bucks or 14 bucks or 16 bucks for a blade. So
right.
You got to sharpen a lot of blades to pay that back. So Karen will measure the diameter of the blade, determine how many teeth are on that blade, determine the kerf and the grind that we want on the blade. She'll program it into the computer, and she'll go down and get the stone close and push go. And it's not quite that easy, is it, Karen? But I made it sound easier than it is. But it's easier than the old stuff. Yeah. When it comes to a circular cold saw blade, there is no one in this country that makes the blank. Nobody. We buy all of our blades and all of our blanks. They all come from Italy, but you can buy them from Europe or you can buy them from China. But you cannot buy a raw blank that's made in this country. There's no one that does it. No one.
There's no production of the material in that dimension, so you just don't even.
No. And it's a tool steel sort.
Right.
It's hardened at about. These blades are almost brittle. They're at about 61, 62 Rockwell.
Sure.
And that's to the breaking point where they can break easy, but no one makes them. The day my dad died.
Oh.
Okay. And all the employees donated a little vacation time to pay for this machine.
Got it.
And then we took it over to the memorial service that we had, and people that came to memorial signed the machines. This is the rear cover of the machine, but so this machine's kind of special for us. Again, it was the last machine we built today. Died. So
wow.
So it'll sit here for
forever.
Forever. Yeah.
Yeah.
Created a legacy.
That's right.
Yeah. Absolutely.
Yeah. Like I say, he graduated the 8th grade.
Right. Yeah.
Yeah, that's phenomenal.
His claim to fame, and he was true. He wasn't accurate. He said, I wasn't the smartest guy, but I was smart enough to hire the right people to do the job. But
sure.
He didn't take near enough credit for what he was doing either. But
sure.
So.
Yeah. Awesome. So we just want to say thank you from the Cole crew to Scotchman Industries for having us out, to Jerry and Brooke for walking us around, giving us the full, very in-depth shop tour. What an amazing place. And we hope to do many more of these on the American Made Shop Tour series. So thanks again. Hope you enjoyed what you watched, and come back for more.